This is the part 1 video for chapter 8. Chapter 8 is on hypothesis testing. 8.1 is basics of hypothesis. And the next few chapters, actually the rest of the semester almost for us, will have hypothesis testing in it. So getting this core concept in chapter 8 is really important. So a hypothesis is a claim or statement about a property of a population. And this is a claim that you want to investigate. So it's a claim you want to investigate. And a hypothesis test, or test of significance, is a procedure for testing a claim about a property of a population. So steps for hypothesis testing is going to be to make a statement regarding the nature of the population, collect your evidence, this is going to be your sample data, to test the statement. You're going to analyze the data and answer if the plausibility of the statement works or not. So we have two different key things here. One of them is going to be the null hypothesis, and the other one is the alternative hypothesis. So our null hypothesis is denoted H0, is a statement to be tested. So this is a statement that is assumed true until evidence indicates otherwise. So this is our default. And so this is the currently accepted value for a parameter. So this is what we're accepting at this time. The alternative hypothesis, denoted H1, is the hypothesis that the sample observations are influenced by some non-random cause. So this is what you're trying to test. So what we are testing. For example, suppose we want to determine whether a coin was fair and balanced. A null hypothesis might be that half the flips would result in heads and half of them would result in tails. An alternative hypothesis might be that the number of heads and tails would be different. So symbolically, these hypotheses would be expressed as, so we have again our null and our alternative written right here. You'll notice the H0 and H1. And you'll notice that we have a P here, this P, and you'll notice it's in both the null and the alternative stands for proportions. And since that's what we're dealing with here, we would have proportions, but you could also have the mean, we can have the standard deviation, or we can have the variance. So it could be different symbols depending on the problem and what we're actually testing. And then you'll notice that we have an equal sign in our null. That's always going to be the case. And then for H1, which is our alternative, I have 3 different symbols here. And no, you're not going to write all 3 of them. You're just going to select one. And it depends on if you think maybe something's different, that would be not equals to. If you think maybe heads, or that the proportion of heads would be greater than 0.5, then you use the greater than symbol or less than symbol, depending on the wording that's written in that problem. So we have 3 ways to set up our null and alternative hypotheses. So we have 3 different ways on here. And if you look at these, you'll notice that H0 is the same for all 3 cases. So it says the parameter is equal to some value. The difference here is going to be in H1. You'll notice it still says parameter and some value for all of them, but the difference here is going to be the symbols. So you'll notice for the first one, we have a not equals to, then we have a less than, and then we have a greater than. And so for the first one that we have, this is not equal to, and this is called a two-tailed test. And so we're going to go ahead and draw a bell-shaped curve here. And since it's a two-tailed test, that means that we are going to be looking at not equals to these little areas over here, and we'll talk more about it as we get into this. If it is a left-tailed test with that less than symbol there, we have our normal curve, but that little area, and again, we'll talk more about it, would be only on the left side. And likewise for our right-tailed test with that greater than symbol, that little shaded area is just going to be on the right. So something to keep in mind as we're going through this and introducing this idea. So the example right below says the null and alternative hypotheses are given. Determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed, and then which parameter is being tested. Again, that parameter is either going to be P for proportions, mu for means, sigma for standard deviation, or sigma squared for variance. So if you look at part A, it says our null is P is equal to 0.2 and H1 is going to be P is less than 0.2. And so looking at this symbol here, we can tell that this is a left tail test. And then the parameter that we are talking about in this problem is that P, which stands for proportions, which again is like a probability or percentage, if you want to think of it that way. For part B, H naught is going to be sigma is equal to 0.76, and H1 is sigma is greater than 0.76. So because we have a greater than symbol here, we do have a right tail test. And you'll notice that the parameter that we're using is going to be the same in the null and the alternative, and it's sigma, and sigma stands for standard deviation. At the top of the next page, we have another example that determines the null and the alternative hypotheses. So this time we're going to be coming up with this by ourselves. And so carefully read the problem, and you're going to be looking for keywords that would indicate what the parameter is, and then also what type of test it would be, if it's left-tailed, right-tailed, or two-tailed. So part A says, according to the National Association of Home Builders, the mean price of an existing single-family home in 2024 was $518,000. A real estate broker believes that because of shifts in buyer confidence, the mean price has decreased since then. So a couple things to note here is that we are talking about the mean price. And so since we know it's mean, that's going to be my parameter. And so I'm going to start off with H naught and H1. That way I symbolize exactly which one is my null and which one is my alternative. Since we are talking about the mean price, I'm going to put mu for both of these. Remember that your null always has an equal sign. So go ahead and put an equal sign. And then you'll notice that the wording here is that it has decreased since then. So for my alternative, I'm going to put a less than symbol here. And the amount that we are talking about is $518,000. So I'm going to go ahead and write 518,000, and that same number would be used for both the null and the alternative. Part B says in 2023, the standard deviation SAT score for the critical reading test for all students taking the exam was 112. A teacher believes that due to changes in high school curricula, the standard deviation of critical reading test scores are different than they were in 2023. So we're going to go ahead and write down H naught and H1. And since we're talking about the standard deviation, we're going to go ahead and put a sigma on both of these. For your null, we are going to have an equal sign. And then it says that they are different than what we had in 2023. So we're going to go ahead and put a not equals to symbol. And the number that we're talking about here is 112. So this is our null and our alternative. So this is our interesting part here with errors, because we could have errors that are going to occur with this. And so we have 4 outcomes from hypothesis testing. One is going to be to reject the null hypothesis when the alternative hypothesis is true, and that is a true thing to do. And then number 2 says do not reject the null hypothesis when the null hypothesis is true, and that's also correct. That's okay to do. But then we have a couple errors. We have what's called a type 1 error and a type 2 error. So for type 1, it says reject the null hypothesis when the null hypothesis is true. So this is incorrect, and it's called a type 1 error. Likewise, 4 says do not reject the null hypothesis when the alternative hypothesis is true. That also means that the null would be false. So our null is false. And the decision would be incorrect. And this type of error is a type 2 error. So with this said, there's a couple things I want you guys to realize is that with errors, we never are going to fully accept anything. So as you're writing your null and your alternative hypotheses, we're never going to say the words that I accept it, because there's always that possibility of an error. So we'll talk about wordings that we're going to be using, but just getting used to the idea that we do not ever in this class use the word accept when we talk about hypothesis testing. So the 4 outcomes are given in a table down below, and you'll notice that it says if H naught is true or false, and then the decision if you do not reject or if you reject your null H naught. You'll notice that we do not again use those words accept. Instead, what we're going to be using is rejecting or do not reject. So the process of testing hypotheses can be compared to court trials. A person comes into court charged with a crime, and a jury must decide whether the person is innocent, which is our null hypothesis, you're innocent until you're proven guilty, or guilty, which is our alternative hypothesis. even though the person is charged with the crime at the beginning of the trial and until the jury declares otherwise, the accused is assumed to be innocent. Only if overwhelming evidence of the person's guilt can be shown is the jury expected to declare the person guilty. Otherwise, the person is considered innocent. So a couple things with this is that most of us are aware that there are errors that occur in a jury trial. So sometimes people are convicted of a crime that they didn't do, and then other times they're guilty and they were set free. So it says in a jury trial, there are two types of errors. Type 1, which is what we have first. So type 1 error is the person is innocent, but the jury finds the person guilty. And then our type 2 error is going to be the person is guilty, but the jury declares the person to be innocent. These two errors, along with the correct decisions, are shown in the table below, where the jury decision is shown in bold on the left margin and the true state of the affairs of the person is shown in bold on the top of the table. And so you can see, just like above in the previous table, it's the same type of layout with two correct decisions and then two different types of errors. So a couple different wordings here. The first one's going to be the first Greek letter we have is called alpha. And these are the probability of making a type 1 or type 2 error. So alpha is the probability of a type 1 error, which is the probability of rejecting H naught when H naught is true. And again, remember H naught is your null hypothesis. And then we have what's called beta. And beta almost looks like a B but with a tail. And this is the probability of a type 2 error. This is probability of not rejecting H naught when H1 is true. Or in other words, the H null or a null hypothesis is false. So at the top of the next page, we have an example. And you'll notice that it's going to look very similar to stuff that we've already seen. So this one says, according to the National Association of Home Builders, the mean price of an existing single-family home in 2024 was $518,000. A real estate broker believes that because of shifts in buyer confidence, the mean price has decreased since then. From the previous example, we determined what the null and the alternative hypotheses are. In part A and part B for this problem, you'll notice it's asking about type 1 error and type 2 error. So the first thing I'm going to do is copy down our null and our alternative hypotheses that we had from before. So our null was that the mean is equal to 518,000. And our alternative is going to be the mean is less than 518,000. So what we have for a type 1 error from before on the previous page is that we're going to reject H naught when H naught is true. So when H naught is true. So for us, for this specific problem, that means we're going to reject H naught, and H naught is going to be that the mean price is equal to 518,000 when, so we rejected that when it actually is true. So when the mean equals 518,000 is true. So we kind of wrote it down with symbols, but let's write it in actual words. And so we're going to say the sample evidence led the real estate broker. So our evidence that we collected led the real estate broker to conclude that, so to conclude that the mean, and we're going to talk about what the problem talks about, which is the mean price of an existing family home has decreased. So we rejected that null because we rejected our null. That means that we actually went with our alternative. So decreased when, in fact, it has not decreased. Another thing to know here is that we're saying it has not decreased. You could say that it has stayed at 518,000 is another way to word this, but we cannot say that it increased since we did not test that. So part B, we're going to do the same exact idea, but we're talking about now a type 2 error. So type 2 error is going to be do not reject H naught when H naught is false. So for our specific problem, we do not reject our null, and our null here is that the mean price is going to be 518,000. So do not reject the mean is equal to 518,000 when in fact H naught is false. So our H naught is when it is $518,000 is false. So this means that it would have actually, our mean would have been less than 518,000. So is not false. So now we are going to write this with our wording. And so we're going to start off the same way and say the sample evidence did not lead the real estate broker to conclude that the mean price of an existing single-family home decreased when in fact the mean, so when in fact the mean price did decrease. So right below this we have the level of significance, and this is a fixed probability of wrongly rejecting the null hypothesis, H naught, if it is in fact true. This is the probability of making a type 1 error, and it is the probability of a type 1 error and is set by the investigator in relation to the consequences of such an error. That is, we want to make the significance level as small as possible in order to protect the null hypothesis and to prevent as far as possible the investigation from inadvertently making a false claim. The significance level is usually denoted by alpha, since that's again our type 1 error symbol that we're using. Significance level is equal to the probability of a type 1 error, which is equal to alpha. And usually the significance level is chosen by the investigator, and it's usually a decimal. So it's going to be something like 0.05, which is the most commonly used one, or 5%. We do use other decimals, but the largest one used is going to be that 0.05. It says an inverse relationship exists between alpha and beta, making the probability of a type 1 increases, the probability of a type 2 decreases, and vice versa. And then the next part that we have done here is stating conclusions for our hypothesis testing. This is where I feel like the class kind of changes, and we're going to be writing a lot more. It's going to feel a little bit more like an English class. So for this, we always write about H1. And H1 again is what we are testing. So what we are testing. And that's what we're going to talk about when we talk about our conclusions and what we write about. Again, remember to make sure that you're handwriting your conclusions. So once the decision whether or not to reject the null hypothesis is made, the researcher must state his or her conclusion. Sample evidence can never prove the null to be true, but we're not rejecting the null hypothesis. We're saying that evidence indicates that the null hypothesis could be true. And again, we do not use that word except. So the example at the top of the next page says, according to the National Association of Home Builders, the mean price of an existing single-family home in 2024 was $518,000. A real estate broker believes that because of shifts in buyer confidence, the mean price has decreased since then. So we've seen this problem before, and I'm going to go ahead and copy down what we've had is that our null and our alternative. So we have that the mean is equal to 518,000, and our alternative is going to be that has decreased. So 518,000, the mean is less than that. And for this, it says the null hypothesis for the problem is not rejected. It says state the conclusion based upon the results of the test. So since it's not rejected, so for this, it says the null hypothesis for a problem is not rejected. That means that this guy right here that we were assuming true is what we are actually going to go with. And that means that the thing that we were testing, which was that the mean is decreased of 518,000, was rejected. So there is not sufficient evidence. And again, we talk about what we are testing, so there's not enough evidence, so there's not sufficient evidence to conclude that we need to talk about what the problem is discussing, and that was that the mean price of an existing single-family home, so single-family home has, and again we need to talk about H1, and we're saying that it has decreased from the 2024 value of $518,000. The next example says in 2023, the standard deviation SAT scores on the critical reading test for all students taking the exam was 112. A researcher believes that due to changes in high school curricula, the standard deviation SAT critical reading scores is different than it was in 2023. So again, we're going to write down our null and our alternative. And for this, we're talking standard deviation. We've done this already once, but equals for our null and not equals to, since it says different, for our alternative hypotheses. And for this problem says the null hypothesis for this problem was not rejected. It says state the conclusion based upon the results of this test. So again, we always talk about H1, and so that means that our null was not rejected, and that means that H1, that idea that we had, that this teacher had, was rejected. So there is not sufficient evidence to conclude that and again, we need to talk about this problem, which is the standard deviation. So the standard deviation of SAT critical reading scores is different from the 2023 value of 112. And again, make sure that when you do this, you always discuss H1, and H1 was saying that was different from that value that we had in 2023. The other thing I want to note is that when we do not reject, we do not have enough sufficient evidence. Make sure that you get used to using these specific words. This is the way that our book does this and that our homework will also display. So the next example that we have is going to be, according to a study, the mean monthly cell phone bill was $73 in 2020. A researcher suspects that the mean monthly cell phone bill is more expensive today. So we have a new problem now, so we have to write our null and our alternative. And it does say the words mean in here, so I'm going to go ahead and put mu down for both our null and our alternative. Your null always has an equal sign, and it does say more expensive, so that would mean it's greater than, it's increased. And the amount that we have is $73. So the next thing that's on here says the null hypothesis for the problem is rejected. So that means our null was rejected, and this time we're actually going with and not rejecting H1. So this time it's saying there is not sufficient evidence. We have evidence now. What we were testing and what we thought is actually what we are not rejecting. So it's what we are going with this study. So we're going to say there is sufficient evidence to conclude that, and again, talking about this problem, which is about the mean monthly cell phone bill and again, writing it in terms of H1, and that was that it is more expensive than the 2020 amount of $73. So a couple things is that our language in English is a little confusing because we have words that mean the same thing. So a couple things to note here is that not rejecting is also the same as saying fail to reject. So another wording for not rejected you could say is fail to reject. So just kind of be mindful of that. Right underneath these examples, it says the test statistic is a value in making a decision about the null hypothesis. It is found by converting the sample statistics, such as P hat X bar or S, to a score such as Z, T, or chi-squared, with the assumption that the null hypothesis is true. So again, under that assumption that the null hypothesis is true, and we have a table down below going over those different parameters, the sampling distribution, the requirements that you would have to check, and your test statistic. Luckily for us, we use our calculator, so many of these things that we are requiring with formulas will actually be easily calculated. Right below this, we have what's called a critical region, or in other words, a rejection region. And it says, in this area corresponding to all values of the test statistic that it causes to reject the null hypothesis. So at the top of the next page, there's 3 different methods to determine the null hypothesis, if it's rejected or not rejected. It says our course is going to primarily focus on our p-value method, so definitely make a note of that. So the first method that we have is called the traditional method. And so for this, I drew 3 different normal curves on here, and we have a 2-tailed, left-tailed, right-tailed test. So we have where it says reject H0, this is our rejection region, like we kind of talked about. So this is our rejection region. And likewise, you can see the left-tailed test, it's over here, and the right-tailed test, you can see it's over there. And so we're going to find the critical value that corresponds to the significance level. If the test statistic's in the critical or the rejection region, then we reject the null hypothesis. The next method that we have is called our confidence interval method. And so this must be to do a confidence interval, it must be a two-tailed test. And that's, again, remember, because you're between two values, you got a lower bound and an upper bound. So we do need it to be a two-tailed test. And so for this, it says, if the confidence interval contains the population parameter, then we do not reject the null hypothesis. If the confidence interval does not contain the population parameter, then we reject the null hypothesis. The next method that we have is called the p-value method. And so what a p-value is the probability of getting a value of a test statistic that is at least as extreme as the test statistic. And it says obtained from the sample data, assuming that the null hypothesis is true. So in other words, our p-value is the probability of what you observe randomly occurring if the null hypothesis is true. And so for that, a way to think about it is if you did have a fair coin and you were to flip it, let's say 10 times, and you got all heads, that probability is going to be really small. The likelihood of that occurring is really small if that is a fair coin. And so that p-value would be really small. And so you'll notice the same three graphs that we have, those normal curves, the rejection regions with the two-tailed, left-tailed, right-tailed test. And so for our p-value method, we are going to find the p-value. And this is done on a calculator. And we're going to round it. It's typically 4 decimal places, but definitely redirections. And what we have is if the p-value is less than or equal to alpha, and remember alpha was the probability of making a type 1 error or a significance level, this means it's in the rejection region. Then we're going to reject H naught. Otherwise, we do not reject H naught. And so the p-value method, it says to use the p-value to make a conclusion about a hypothesis, compare the p-value with alpha. And so it is also written here. So definitely give that a couple stars, something we need to know for our homework and quizzes and exams. And then I also wrote it down a little bit more with sentence formats and right below this. So it's at the bottom of page 5. So definitely look through that. But if the p-value is less than or equal to alpha, we reject our null. And if the p-value is greater than alpha, then we do not reject the null. So at the top of the next page, we have an example. It says, suppose we're testing the hypothesis H naught, which is p equals 0.3, versus H1, which is p is greater than 0.3. And we find the p-value to be 0.23. Let alpha equal 0.10. Explain what this meaning is, and would you reject the null hypothesis and why? So there's a couple questions in here. First thing is that if the p-value is equal to 0.23, so if the p-value is equal to 0.23, we would expect at least as extreme as the test statistic in about 23% of the samples. If the null is true. So if the null is true. The second part of this question does say, would you reject the null hypothesis and why? And so since our p-value is equal to 0.23, we need to compare this, and I'll put a box here and put my symbol in just a sec, but we need to compare it to alpha, which is 0.10, and that was given to us up above. And so for this, you'll notice that your p-value is greater than alpha. And so when your p-value is larger than alpha, you do not reject our null, which is H naught. And that was based upon that p-value method on the previous page. The next example right below says the test statistic of z equals 1 is obtained by testing the claim that p is greater than 0.3. So part A says to identify the hypothesis test as being two-tailed, left-tailed, or right-tailed. And since we have a greater than symbol here with greater than 0.3, we know that this is going to be a right-tailed test. So right-tailed test. And then it says state the null and the alternative hypotheses. So we're going to write down H0 and H1. So a little different here because it's given partially to you with symbols. So again, remember that your null is always going to have an equal sign. So that P greater than 0.3 would actually be our alternative. And that means that our null is going to also have a P here, also have a 0.3 here, but always has an equal symbol. So the next one says find the p-value. So I'm going to go ahead and sketch a normal curve here. And it does use the letter Z. And if we remember, that's our standard normal curve. That means that it has a mean of 0 and a standard deviation of 1. And so I'm going to go ahead and put 1 on here. And I did that because it says Z is equal to 1. And it is a right-tailed test, so I am going to shade this to the right. And so this area that we have here is going to be what's called our p-value. And so in order to find the p-value with this type of problem, we need to use normal CDF on our calculator, our lower bound, which is starting at 1, our upper bound, which goes on forever, so that's 1E99, our mean, which is 0, standard deviation, which is 1. On your graphing calculator, you're going to go to second distribution, or second bars to distributions, go to normal CDF. Our lower bound is going to be 1, comma, our upper bound, which is that 1E99, so 1 second, comma, which is that E99, comma, our mean, which is 0, comma, standard deviation, which is 1, close your parentheses, select enter, and again, round this 4 decimal places. From the graphing calculator, rounding 4 decimal places, we get our p-values equal to 0.1587. Part D says using the significance level of 0.05 for alpha, should we reject the null or fail to reject the null? And it does say explain. So our p-value is equal to 0.1587, and we need to compare this, and I put a box there, I'll put my symbol in just a sec, to alpha, which was given as 0.05, and so our p-value is greater than alpha, and so this means that we do not reject H0. And again, remember, you could also word this as fail to reject H0. And again, the reason why is because our p-value is greater than alpha.